Hello and welcome to Techie Hive. Today we'll talk about Java generics and question is on your screen. What are generics in Java? How do generics provide type safety? What are limitations of generics in Java? So by asking this question, interviewer wants to understand that you know Java generics and you understand how Java generics are used for Java library component. Let's go to the answer. Generics in Java are a feature that let you write classes, interfaces, and methods that work with different data types while providing compile time type safety. They were introduced in Java 5 to eliminate many runtime class cast exception and reduce the need for the explicit casting. So generics got introduced in Java 5 and they got introduced mainly to fix the uh, class cast exceptions and provides type safety. Let's understand it by a simple example. Here we have created a list without generics and with generics, and our purpose is to create a list of strings. So in the example without generics, compiler is allowing us to add integer to the list of strings. So here we want to have list of the strings, but compiler is allowing to add integer. So in this case, if we have added an integer to the list and we want to get the element from the list, and we typecast it, because in the case of without generics we have to typecast it what type of elements are there, and if we have a integer and we are typecasting to a string, it will show runtime error. So that means the compiler is allowing to store different types of elements in the list. On other hand, you can see here we have specified that this list will have only the strings. So here we have specified generic types string here. And now when we try to add hello to this list, it's allowed. But when we try to add integer, it shows compile time error. So errors are caught in the compile time phase. They are not traveled to the runtime phase, and they will avoid class cast exception. Next, let's see how to create a generic class and a generic method. Here is the example of a simple generic class box, and you can see we are specifying generic type T, and then we are using this T to specify the type of the field, and also we are passing this type to the methods. And if we want to create object of this class, then we can specify this generic type while creating the object like this. On the right hand side, you can see box integer, box equal to a new box. So here we are specifying the generic type T is integer. So this box will contain integers. And in the second example, we have specified generic type string, and we are creating the object of a box class. And now this box class, like box2, will contain uh, strings. Let's go to the generic method next. Here we have given two examples of generic method. In the first example, we have specified two generic types U and V, and we are returning V from method process and passing U as the argument. And in the body, we are just processing this A, and after processing done, we are returning V. So this is the syntax of writing generic Java methods. In another example, we have specified only one generic type T, and after that we are just using the T to pass the argument, and after that we are printing all of the elements of the array. And examples of the example one are here. You can see here long A equal to process 100. So we are passing integer 100 to the process method, and then process method is returning long over here. Similarly, in the second example, we are passing byte to the method and returning integer. And in the another example, we are passing integer of array of integers and then printing them. And similarly, we are passing array of characters and printing them. So you can see here that generic class and generic methods are very simple, and we just need to specify the type when we create the objects on generic class. Let's see how to restrict the generic type in Java. And here is the example of the upper bound. So an upper bound means the generic type must be a specific class or interface or any of its subclass. And here is a syntax: T extends some type. Then here any type which extends some type can be passed, as the type. And here we have anything which extends some type can be passed. And here is a simple example of upper bound. We have created a simple method sum, and we are passing a list of numbers to the method. And here we have specified upper bound. So it says anything extends number. So anything that extends number can be passed to this method to create the sum. And here are the valid argument. So integer, because integer is extended from uh, number, right? So that means integer, double, and the number itself are valid arguments because they are like integer and double extend number, and number itself is the valid argument. Invalid argument. So to this method we cannot pass list string because string doesn't extend number, and also any other class doesn't extend number. So here we are restricting the generic type to have a specific types of the arguments. And key points of this upper bound are: you can read items safely as some type. So you can read items, but you cannot update them. Remember, you cannot update them when you have a upper bound. And upper bound is used when collection produce data. So remember, when we have collection and we want to give that collection to someone to process, then we have to use upper bound. Let's move to the another restriction, and this is called lower bound. A lower bound means the generic type must be a specific class or any of its superclass. So here we can see that in the case of lower bound, super is used instead of extend. So here T, uh, which is super of some type, can be used as type, and also anything which is super of some type can be used as type. And here's the simple example. And in this example, we are just passing a list of the integers to the method, and then we are updating the list. And you can see here, this is the lower bound because we are using super. So anything which is super class of integer can be passed as the argument here. So valid examples, list integer because integer can be passed itself, and number and object, they are superclass of the integers. So now invalid argument, list double. Double is not part is not superclass of integer, so you cannot pass double to this method. So key points which you need to remember about lower bound: you can add items of some type. So in the case of lower bound, you can add items, and on the other hand, in the upper bound, you can only read the items, you cannot update them. And here they are used when we want to consume the data, when we want to update the data in the collection. So we use lower bound. So remember, when we want to read data from the collection, then use upper bound, and we want to update the data in the collection, use lower bound. Let's move to the limitations of generic types. So in Java, generic types make code safer and reusable, correct? But they also have some important limitations. These mostly come from type eraser and design choice in Java. So first, main limitation of generic type is type eraser. So what happens when we use generics in our program? Then when program is compiled, all of the generic types are converted to their base class. So here, string will be converted to object, and also integer will be converted to object. And at runtime, the class of the list one and list two would be same. So it's very difficult to find out which string is sorry which list is for a string and which list for integer. So type eraser is the main limitation of the generics. Second limitation here is that we cannot create object of that generic type here like this. So this statement is not allowed. So here we have t generic type. So here compiler doesn't know like what type is this at the moment. So this is the another limitation. Next limitation is that we cannot create array of the generic types. So Java doesn't allow to create arrays of generic types. Then fourth limitation is that static member cannot be generic. And fifth, we cannot overload methods with the same eraser. So you can see here we have two methods. At compile time, they looks good, but what happens when they are compiled to the uh, same eraser? So what will happen here? This method will be converted to list object list, and this method will convert to list object list. So that means at runtime they will look like same objects, sorry, same methods, and it will show the runtime error. So these are few limitations of generics. Okay, that's all I wanted to cover in this video. Hope you like it. See you in next video.